Hello and welcome to another edition of the Yeasu 897. When I did the last video where I replaced the encoder on the front panel, I had mentioned that this was also in to have the IF filters changed, and I was not going to do a video on that because so many other people had done them. Well, I've changed that opinion, and I am going to do a video on this because I believe there's a lot of bad information being circulated around, which is not uncommon for YouTube. Somebody hears an idea, they seem to think it has merit, so they repeat it. Somebody else hears that, repeats it, and the next thing you know, it becomes fact. I think I'm going to blow a hole in some of those theories. When I opened this up initially and looked at the top of these IF filters, and these are made by Toco, and these are used by Kenwood as well, and Kenwood has the same issue as these Yeasus do. They were covered on the top with what look like salt crystals. It's the only way I can describe it, is like salt from like you'd have in your car after all winter if you hadn't washed it. And there were also beads of what I can only call sweat. It actually had little beads of moisture on the surface of these. Now bear in mind, the humidity here in the lab is under 30%. This is a very dry environment. And the radio came from a warm home in the guy's Radio Shack. It hadn't been out in the car. But they were covered with little beads of sweat. Now, the underlying theory that's going around on the internet at this point is these are failing because they have DC bias on them. And the story is that, that every manufacturer says you can't put DC on these ceramic filters. It'll destroy them. I have searched through every manufacturer of ceramic filters I can find, and I cannot find a single reference that says you cannot have DC bias on these or that it will cause damage. I went to the Murata Toco website, and it says here, quote, "If our ceramic filter is impressed with DC for a long time, it will almost for sure not cause a problem." And you have to interpret the Japanese English. It says, rarely defect may cause. And what they're saying is there's not much chance it's going to damage the filter. It also says on another page of their data sheet that for safety purposes, the output, you might want to put a DC blocking capacitor for safety. And what they're meaning here is avoid applying direct current to the output because it might damage the following stage. Well, we have a dozen manufacturers using these and a dozen manufacturers running these without blocking capacitors. I can't believe they're all wrong. Somebody read this and interpreted that as all manufacturers say that you can't have a DC bias on these, and I'm not buying it. What's happening here is the plastic that they used on these is hygroscopic. It will absorb moisture on a very damp day, and on dry conditions it will give it up. That is borne out, bear with me here, that is borne out. There's a dozen videos of people cutting these things open, and the inside of these is wet. And there's been comments on one of the videos. The guy took the pieces, dried them, put them in a jar on a shelf, and came back a few months later, and they were wet again. They had been pulling moisture out of the air. And before you tell me that plastic can't absorb moisture, back up. Plastic most certainly does. Some different plastics certainly do absorb moisture. This radio is almost 10 years old, or is 10 years old at this point. Integrated circuits from 10 years ago used to say right on the packaging that they had a very limited shelf life before they absorbed so much moisture you couldn't do wave soldering. They would explode in the wave soldering machine because they would build up steam pressure because of the moisture that the plastic encapsulation would absorb. I have plastic rivets out in the garage that I use. You probably saw my Dodge Dakota repair, and I used plastic rivets to put the inner fender wells back in. The box clearly states that if those rivets are used in a dry environment, they should be soaked for 24 hours in a jar of water before they are used to prevent them from getting brittle. In other words, let them absorb moisture and they'll work correctly. So my theory is these do not need DC blocking capacitors. What they need is and these are by a different manufacturer, and I went to the LTM website. They say nothing about using blocking capacitors. They call these a direct replacement for the Tocos and Yeasu and Kenwood equipment. These are direct plug-in pin-for-pin replacement for the Toco IF filters. Nowhere do they say it needs to have a DC blocking capacitor. And by the way, these aren't very expensive. These are, I've seen them $3 or $4 a piece on eBay, and eBay usually has high prices. Rather than carve up a circuit board and a radio that's fairly expensive to install blocking capacitors, I would rather buy an extra set of these and just have them laying around so that 10 years from now, if I have to, I can replace them again. The symptoms on this radio, it's basically deaf as a stump, and that's pretty common for when these fail. And they also, when they fail, show a short to ground, and I'm going to check that when we pull the board out of here. It's because the insides of these things corrode. Does the DC bias push that along a little bit? Possibly. In any rate, or at any rate, they are going to fail irregardless of DC on them or not. And again, carving up the board, in my opinion, is not the way to go. I'm going to talk to the owner of this radio and tell him I will replace the filters, but I do not recommend cutting up the board and putting blocking caps in. And if you look at the videos of the guys breaking these things open, because it's probably one of the safest ways to get them off the board is to cut them open and pull the pins out individually rather than trying to use a desoldering tool. There's so much circuitry in close proximity here. They are full of a wet green slimy corrosion. And it's that same green corrosion you see when copper leaches through plating when it gets wet. The plates between the little ceramic pieces are probably silver-plated copper. And due to the moisture, the copper is leaching out and contaminating the ceramic and producing a path to ground. Plus, it's insulating between the individual ceramic parts that are in here. There's a plate and a ceramic piece and another plate, and it's like a sandwich down through here. I'll pull one apart when we get further in here. That's what's causing them to fail. And I know somebody's going to say, oh, the DC current is creating a path and it's creating dendrites, and they're going to... Well, the DC current may be doing that. This is very similar to... what's called silver mica disease. The antique radio guys will tell you about silver mica disease in the IF cans, and that's a real phenomenon. It happens. But it's not the primary cause for failure here. The primary cause is these things are absorbing humidity and failing. I'm hoping that this other manufacturer is using a different formulation in the plastic. But again, we're going to plug these in, we'll put them in the radio, see if it improves, and then I'm going to talk to the owner and recommend that I don't carve the board up and put blocking capacitors in there. I do not personally believe they are necessary. If you've watched my previous video, you've seen how the covers come off. We're going to move forward to removing this circuit board so that I have access to the back side of the board so that we can remove these old filters. And there are 3 different filters. There's a 455E, a 455G, and a 455H. And underneath these on the board, they will be marked E, G, and H. So just make sure that when you replace these, you put the right one in the right position. They have different bandwidths. This filter and this filter are for the AM sideband operation. This filter and this radio are for the FM, wideband and narrowband FM, or wider audio band. It's the 455 KC filters. So we'll get this board out of here. I'll show you how that's done and we'll proceed on. Okay, we're going to start the removal process of this board by pulling all of the connectors and getting those out of the way. There's not a lot on this board. We have a ribbon cable, we have a coaxial connector here and here, and a couple of multi-pin plug-in connectors here. There isn't anything else on here to worry about. These connectors are different pins, different numbers of pins, so virtually impossible to confuse. This red one is too short to reach over here, and the green one's obviously too long to go here. The little ribbon cable, there's only one. So I'm going to start by gently twisting the little coaxial connector, not the wire, and I've broken it free, and now I'm just going to gently pull it out. There's a little hole down right here. These can be a bear to release if you don't know the trick. I center the wire under the middle of it because the middle is where there's an opening. I take a wide bladed screwdriver and gently pry the 2 sides apart, and of course doing it on camera, there it is, it just pops right out. So that one's out of its little retainer. I'm going to use a pair of small pliers on here because I can't get my fingers in there. I'm just going to gently work it to break the friction loose. That one's out. The little ribbon cable, very gently lift it up. I'm going to get underneath it and I'm going to pinch it right down near, there's a blue reinforcement strip, and I'm just going to rock it out. Very carefully rock that out. That one's out of the way. These 2 connectors, I'm grabbing it by the connector and gently rocking it out. You don't want to pull on the wires, you'll pull the wires out of the plugs. Again, gently rock it out. If you can't get a hold of it, take a couple of small screwdrivers and work it up from the sides. And I should mention, there's a lot of static sensitive parts in here. You can probably hear my benchtop ionizer whining away very gently, quietly over there. That's flooding this whole area in ionized air, which will dissipate static. I have my anti-static mat. I've sprayed the area because it's very dry in the lab here. It's like 30% humidity. I've sprayed the area with Static Guard, and there's cling-free Static Guard. Any of those things will work. Have your girlfriend or wife bring something home from the grocery store. Bring a couple of them home. They're cheap. It only lasts a few hours, but it's a good hedge against building static as you move around in the lab. I spray my chair, I spray my clothes, and I'm wearing an ankle strap. I find a wrist strap a pain in the neck, so I just put one around my ankle and work that way. Sometimes I forget and walk off with it attached, but they're cheap. At any rate, we're going to remove the screws around the periphery, these larger flathead screws. I don't remember, but on this radio, I don't know if I have to remove that one there. It's a different type of screw, and I suspect not. There's one in the heat sink here on this little amplifier, I believe that is, from the number of pins on it. I think we have a voltage regulator here. These go down to bosses, so anything that goes down to a boss, and you can see the boss underneath here, you probably can't see it in the camera. We're going to pull out these larger flathead appearing, not flathead, dome head appearing screws, and the board should come loose. It appears I was wrong. I am once in a while. these two screws here apparently do have to come out because everything else is out on the board is still hanging on. I should also point out there are two different length screws here of these. I guess, I don't know, they'll call these dome head, pan head. They, the longer ones, there's two of them, are used on the devices that are connected, you know, for heat sinking purposes. So there's a long one here and a longer one over here on this device. There's only two of them and there's only two devices, so it shouldn't be a problem. We'll pull out these last two screws and hopefully this board will slip out of here. And of course I dropped the lock washer. It's rough working around the camera. Where did the lock washer go? Oh, it's hiding here somewhere. It couldn't have gone far. And we'll find it in a minute. We'll pull the other one out and try not to drop the lock washer for it. Okay, that one's... oh, they're captive. Ha 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 ha. You got to remember, this was built by the Japanese, and the Japanese just do things that make sense. Captive lock washers. So I didn't drop the lock washer. It's right there. Let's see if the board is loose. No, the board appears to be loose. We should be able to slide it back a little bit to get it to clear the connectors. And sure enough, there it is. Aha! That's what the two other screws are for. We have a device under here. It's probably the driver IC is my guess, but I haven't looked at the layout. We'll have to put some fresh heatsink compound on there when we put this back together. So I'm going to get everything cleared out of the way, get the heatsink compound cleaned off of that so that I don't mess up the bench, and we'll be back. Okay, for anyone contemplating doing this job, I do want to point out that the components on here in the vicinity of the filter, let's see, I don't know if I can do this looking through the camera or not. There are resistors. I'm pointing to one right there. And the lead of this pencil is 0.5 millimeters. 22 thousandths. That little resistor that it's pointing to right there is 20 thousandths. It's actually smaller than the lead of the pencil wide, and it's 40 thousandths in length. Double the length is double the width of my pencil lead. Be prepared for tiny surface mount components. Come on, focus. Come on, focus. There we go. These are extremely, extremely tiny components. I am going to put the very smallest tip I have on my desoldering tool to be able to get into here without damaging or moving, disturbing these chip resistors. I'm going to have to be extremely careful, so I'm doing this off camera under high magnification. There's no way I could do this on camera and without damaging something, so I'm going to have to turn the camera off and desolder these. I'm sorry, I'm trying to get this on camera before they evaporate. In the desoldering process, and I don't know if I can get them to reflect or if they can get them visible on the camera, but right here on the side of all three of these it's sweating. All three of these are throwing water out as the heat from the soldering iron gets on. Oh, in fact, it may even be visible here. Can you see the sweat? Can you see the staining? As I warm them up with the soldering iron, these are pushing moisture out through the plastic. And if you need any more proof than that, I don't know what to tell you. They are just... I'm trying to find an angle here. And in the viewfinder, I can't tell if you can see it or not, but there are balls or beads of sweat all along the side of those filters there, and all along the side here. Let me put my magnifier back on. Yeah, they're still there. I just can't see them through the viewfinder. The things are covered in sweat. Let's see if we can... Do they stand out there? I hope they're visible to the camera. These things are just pushing moisture out the side as my desoldering tool heats them up. Okay, I'm going to finish getting them off. I have them off the board. The heating system just started up, so be it. I want to get this before the sweat disappears. Can you see the beads of moisture on the sides of these? And bear in mind, I've been handling these. I've wiped it off a couple of times, and they're still pushing moisture out. Let me see if I can turn them around without brushing the moisture off. Here's the opposite side. I can't see in the viewfinder if there's anything there. Oh yeah, there's some shiny stuff there. You can see it. Okay, enough preaching. Here on the board you can clearly see G, E, and H. And that's where our new filters will be installed. Remember, there's a G filter, an E filter, and an H filter. If I can put my hands on them, here they are. And we'll get these up here on the camera. Right side up, Vern. There's an E, there's a G, and there's an H. So I'll drop those back on the board and we'll get them soldered. It's the next evening. I realized as I was working on this, it was getting on towards 11 in the evening and it was time to get to bed. I've soldered in the 3 new crystal filters or ceramic filters, IF filters. And then as I was getting ready to clean the flux off, I noticed that there was some other areas of flux over here. And I know there was another spot. Where the heck is it? Oh, there's some over here. And then I flipped the board over and fortunately spotted, I don't know if you're going to be able to see this, there's pieces of wire sticking up off the board here. And somebody has obviously soldered some test points onto the board at one point in time. I don't know if the camera's picking those up. I hope it is. And I am so glad I noticed those, because I could have bent those over against one another, put this board back in, blown something up, and wondered what the hell I'd done. That's kind of scary to open it up and see those things. Now I know why the guy did that. It's a place for test points. And but whoever worked on this left them in position, or left them in there, and they are such fine wires that if the light doesn't catch them just right, you can't even see them. Or I can't with my old eyes anyway. So I'm going to remove those, put this board back in, and test the radio. Now I mentioned in the beginning of this, I hope, that this radio was as deaf as a stump. And doing an A-B comparison between the radio at my operating position and this one, a 20 over S9 signal on my other radio didn't even move the S meter on this one, and I am attributing that hopefully to these filters. I hope nothing else is going on here, but we're about to find out. I'm going to clean the flux off the back. I'm going to remove those little wires that are sticking up over here before I have a disaster. And we'll take a look at it when it's back in the radio. And I'm going to have to eat my words. It just dawned on me what those are in there for. Those are jumpers that are across these pads, evidently for an option. Probably to open it up for Mars frequencies or something of that ilk. Somebody's made a change. At least that's what it looks like. There's double pads, and these are jumpering the pads. So what I'm going to do is leave them in place and trim the excess length off so we don't end up with any short circuits here, because that could be ugly. So I'm going to trim off the excess length and leave those in place. Okay, Yahoo, we have a radio again. And every bit as sensitive as my 746 Pro. Right now we're on the 40 meter band, and it's good and noisy as usually is this time of year in the evening. But the radio's back in business.
On the route that I just mentioned. Oh, you may not, but did you download the JT65 program? No, I have not. I'm content right now to play around with Reading and CSK. And,
so as you can see, everything's back to normal. We'll turn that racket down. Now I know I'm going to get a lot of flack for what I said in the beginning of this video about not blocking the DC to those filters. But unless you are a filter design engineer with many years of experience on this, don't bother telling me I'm all wet, because I'll ignore you. It's going to take somebody with a lot of credentials to convince me that I'm wrong about this. I've investigated, or I've researched many filter manufacturers' websites and can find none of them that say that it's detrimental to have DC on the filter. And I think that's one of those myths that's been propagated across the internet by somebody said it, or somebody misread what was on the Toco website, and that's turned into every manufacturer says it, and it's been propagated over and over and over, because I can't find it on any of the data sheets. At any rate, I'm going to stick to those guns until some real engineer tells me otherwise. And again, if you're not an actual ceramic filter design engineer, I'm pretty much going to ignore you. But the radio's up and running. I think the customer is going to be happy. He'll have he's got his sensitivity back. The radio's working well, and I'll tell him if these fail, I'll replace the next set for nothing. For now, I'm the radio mechanic. Hope somebody found this somewhat useful. I know it's going to be controversial, but so be it. See ya.